We are back. Officially, we are back. So, baby, data exfiltration, detection, the premium room. Learn how to detect data exfiltration attempts in various network channels. This one is data exfiltration is unauthorized transfer of sensitive data from computer to another device. Its primary objective for hackers who have breached a network. At the SOC analyst, your job is to detect and stop this before sensitive information walks out the door. This room will cover the common techniques attackers use to steal data and, more important, how to catch them in the act. Learning objectives. This one will cover following learning objectives. Undistinguishable method used for data exfiltration. Learn how to detect exfiltration attempts using network traffic analysis. Identify signs of exfiltration on endpoint devices. Correlate logs in a SIM to uncover hidden exfiltration channels. For this one, we will need Wireshark Basics, Network Security Essentials, Splunk Basics, and Exploring SPL. So baby, before moving forward, start there by clicking just did. I'm in the machine. We have index, can be found in history. This is it. And let me change this one to all the time. All the time. 1800 1700 18,000 170 and complete this one also. So that exfiltration is unauthorized transfer of data from the organization to external destination controlled by adversary. Can be delivered inside real malware compromised credentials. So all malware or compromised credentials, but maybe we have something else in here. Why adversaries perform data exfiltration? Data exfiltration is the act of stealing sensitive information from the network. Adversaries do this for several reasons. Financial gain, stolen data, credit card info, personal credit can be sold in the darknet or used for fraud. Espionage, national state, actors target, intellectual property, trade secrets, and classified data for strategic advantage. Ransomware and extortion. Targets steal data and threat to leak it unless the ransom is paid. Destruction and sabotage. serve adversaries aim to damage reputation or operates by leaking internal data. Persistence and reconnaissance. Exfiltrated data helps attackers understand the environment for future attacks. Threat actors, their exfiltration techniques. The following table covers some of the real-world threat actors and their exfiltration methods. So we have APT29 Cozy Bear, HTTPS over legitimate domains. Encrypted HTTP channels were used to exfiltrate data from government networks. Fin7 HTTP post to C2 command and control infrastructure are the set of programs used to communicate with victim machine. Is comparable to the reverse shell, but generally more advanced and often communicates via common network protocols like HTTP, HTTPS, and DNS. Embedded stolen data in HTTPS post request to avoid evade detection. Luna Spider Z-Loader encrypted HTTP channels maintain 2-month intrusion using encrypted channels and staged exfiltration. Darkside ransomware, dual extortion, encryption and exfil. Store data before encrypting systems, then threaten public clicks. APT10 Cloud Hopper, cloud-to-cloud transfer, exfiltrated data from managed service providers using cloud API. I just wonder if we have cloud-to-cloud transfer. Isn't it suspicious? All these transfers? Just saying. Common phase related to exfiltration. Discovery, collection, attacker locate sensitive files, staging, compression, attacker aggregates, compresses, encrypts or encodes files, zip, bar, 7z, tar, base, 64, steganography, exfiltration, transport. Transfer over network, removable metadata, cloud, convert channels, command and control, coordinations, orchestrates, transfer and configures. Techniques and indicators. Detecting exfiltration requires correlating host and network level indicators such as unusual large or frequent outbound uploads, identifiable, long and high entropy DNS queries. DNS is protocol responsible for resolving hostnames such as TryHackMe DACPA to their respective IP address. So good is that example of DNS tunneling and DNS high entropy is this one. This is it. It is some gibberish with legit domain, and then another jailbreach with data. This one is trying to exfiltrate. Back to the business. Suspicious process, command line and network connection, sysmon EDR, sysmon, system monitor, which is Windows System Service and device driver developed by Microsoft and designed to monitor and log various events happening within a Windows system. Cloud Stage API. Activity removable media events. SOC1 triage focused on source, host, user, destination, transfer, volume, process identity and command line, supporting evidence across proxy and DNS, flow, host and cloud, logs. Network-based. So network-based we have HTTPS, HTTP upload to S3 Azure block, webmail, FTP, SFTP, SCP, DNS downlink, ICMP, convert workloads, custom TCP UDP. Indicators of attack and where to look. Proxy WebGate logs. Large hosts uploads to cloud endpoints. Firewall. New generation firewall. NG. FW flows. High byte signals. IPASN. Let flow. Spikes. Outbound flows. DNS logs. Long host names. TXT queries. Host-based. PowerShell, invoke, web request, arclone, AWS, SCL, curl, widget, archive creation, CRAR, use of removable USB, ADS, hidden streams. Where to look? Sysmon EDR, process creation, network connect, file creation events. Windows security 4663, 4656, object access, audit shell history on Linux and removable media events. Cloud encoding, DNS, base 64 or chunk, encoding steganography into images or audio, splitting files in a many small requests, low and slow. Where to look for? Indicators where to look. DNS logs, proxy logs with many small posts, requests, correlation of intermittent upload, suspicious process activity, insider collaboration tools, selective Dropbox, Google Drive box uploads, and sharing to external users, compromised employee accounts, audit files, share events, file downloads, and mail logs. General IOA triaging signals, large, outbound, volume to external APIs, domains, unknown destination domains, suspicious processes, command lines, many files, read events followed by outbound connection, and multi-path streamed uploads. Correlate, proxy firewall netflow, DNS is mon idéal, event ID 13 or 11, mail, server, logs. Data exfiltration is a high-impact threat that combines opportunistic method, legitimate tools, and creative convert channels to move sensitive assets outside of the organization. An effective detection depends less on single point of alerts and more on a rapid collaboration. Correlation Sharon across host, network and cloud telemetry. Identify how accessed data, what was transferred, how it was staged, and where it was sent. In the coming tasks, we will explore various techniques employed by adversaries to perform data exfiltration and what indicators can help us trace the footprints of the attack. So here we have the question: exfiltrating the data through HTTP, network-based? I guess. That's it, Sharon. DNS exfiltration, abuse the domain name system. The protocol normally allowed through networks to smuggle bytes encoded inside DNS. Queries, responses, soft firewalls, and web proxies don't notice, because DNS is typically allowed and often unfiltered or forwarded to public resolvers. It's attractive to convert channels. So DNS tunneling. We have in here translate human-friendly domain names, DNS, what it does, into IP addresses and provides other record types. A for ACE, text, and X. C name. DNS queries are ubiquitous. Almost every host performs DNS lookups. DNS is normally allowed through firewalls and gateways, making it an attractive convert channel. DNS uses UDP mostly on port 53 for queries and responses. And ECP is used for zone transfers and large response. Why attackers use DNS for exfiltration? Always on service. DNS lookups are routine and often allowed outbound. High cover. DNS query look like normal queries unless inspected closely. Flexible payload data can be encoded into the subdomains, labels, or txt responses. Indicators of attack, IOA. When analyzing DNS traffic for possible indicators of data exfiltration, we should look for many DNS queries assigned to single external domain, especially with very high counts, compared to the baseline. Long subdomain labels or unusual full query names, more than 60 or 100 characters, high entropy or base 32 64 like patterns in query name, lots of mixed case letters, digits, minus and equal signs for base 64. Rare record types, text, null or many large txt responses, unusual responses behavior, frequent NX domain if attacker uses flexi-byte query without answering, TCP large UDP fragments for DNS. There is a regular interval beaconing behavior. So let's see what we got in here. Data Exfil. So we go DNS Exfil. And let me open this one. Filter with DNS. Let me fix this. Let me see. We have queries, nothing in here. And our DNS flag response, DNS flags response 0. Let me see. Google. So we are filtering without response. Find all queries, DNS. Let me see. DNS frame links, then move it 70. Here we go. This is it. Total coordinate. And we are witnessing the long push one. Very nice. Very, very nice. So now DNS query name contains reducted. What's reducted? What's reducted? TT tunnel coordinate. This is what is reducted. Ridiculous. DNS. 3. I cannot follow this one. Let me. Okay. Looks like we have successfully identified the DNS tunneling attack. All the network traffic we can observe. What about internet? Hosts are compromised. All of these hosts are sending data in chunks using the DNS technique. Let me do your heavy. So we can jump real quick. Index.exfil. Now source time DNS logs. In the time range, we have 2000 events. Exactly. So now I have this. This search query will show the result matching source type DNS logs. What to look for? In the DNS logs, we need to look at a special locate domains. Okay. Let me see. Dots. Count boy. SRCIP. So here we go. And now sort minus count. We have nothing. Where are we? So now we have two tunnel coordinate. Long query names. So we can where len query bigger than. Let me see this one. Let me duplicate this one real quick. And now where len is bigger than 30. We have 350. And let me stop. Count. Boy. Yeah. Here we go. What suspicious domain received DNS traffic? That's it. How many suspicious traffic related? 50. Which local app set maximum number of suspicious requests? That's it. Let's move to the next step to detect data exfiltration attack via FTP protocol. Let me see. File transfer protocol is one of the oldest protocols for transferring files between the client and server over TCP/IP network that uses it to move large amount of data of the network, sometimes via compromised credentials, mixed configured servers, or. So I wanted to know what's ephemeral accounts, and I asked our friend Ask Echo. So term ephemeral refers to accounts that research that temporarily and exist for short duration. In the context of data exfiltration, attacker may use ephemeral accounts to gain access to system and transfer large amount of data without leaving a long-term footprint. Those accounts can be created quickly and often have minimal oversight, making them attractive for malicious activities. Detection of such activities relies on various techniques, including packet inspection specific to FTP traffic, analyzing server logs, identifying unusual access pattern, examining SSH sessions, metadata for anomalies, and monitoring network flow for signs and patterns irregularities. By combining those methods, security teams can better identify and mitigate risks associated with data exfiltration through FTP, especially when utilizing ephemeral accounts. So back to business. Detection relies on a mix of packet inspection, FTP-only service logs, SSH metadata, network flow size pattern analysis. How adversaries use FTP for exfiltration. The legitimate FTP servers, public or misconfigured internal service to stage, transfer data, compromised credentials, server accounts, user creds, non-standard ports, or tunneling to blend with their traffic. Indicators of attack, IOA. What to look for: user and pass commands, clear text credentials, ST or upload and read download commands, repeated or large transfers, large data connections to unusual external IPs, especially outside business cells, data channels opening on ephemeral parts, pass-V paired with large payloads. Let's examine. Exfil. Open this one. Now FTP. If I can type DB or FTP data. Let me see if I can follow this one. TCP stream. I can follow this one. User 123 store report. Let me see this one. FTP done. And nothing has happened. So we don't have any data. We can see these ones. User and maybe someone is doing book for maybe, just maybe. So now we will look for FTP request command equal user or FTP request command path. Here we go. Users with no path. No path at all. Let me follow this one. Do have path. So now we can FTP contain is cool. What do we got here? Fairman store report. Nothing new. Maybe the only one new is how many records are displayed. 313. Not bad, not bad. So now I flow. Okay. Just done that. Nothing interesting. Contains CSV. Oh, okay, okay. Yes, CSV. What? Oh, this one is interesting. Root. Contains internal passwords. Dude. Okay. Internal passwords. Let me see. Let me see this one. Not much, not much. Not much, but I can copy this one. Data value. Let me see what I've got. Very nice. So we got the hidden fault. How many connections were observed from the guest account? Guest account. Guest account. What do you mean guest account? Contains guest. Guest. Not much. 5. That's it. Apply the filter set is the name of customer related file exfiltrated from root account. Okay. Root account. Internal passwords. Nope. No internal password. Custom data. That's it. Which internal IP was found to be sending large payload to external IP. Large payload to external IP. Let me see. FTP. And wait. Then 90. Remember large payload. We have 10 in here. Okay, this is it. Large payload. Guess. And the flag we found in what? Chambers. Let's get it on. Data Exfil via HTTP. Data Exfil. When an attacker moves sensitive data out of the target network using HTTP as a transport, HTTP is commonly abused because it blends with normal web traffic, can traverse firewall and boxes and can be obfuscated, encoded, encryption tunnel. This detection task aims to teach SOC analysts how to identify such HTTP-based exfiltration in packet catchers, Wireshark and Splunk, and to provide practical search queries and investigations. Why it matters? HTTP is a very common attack. It's very common. Attackers hide exfiltration in the noise of legitimate web usage. Successful detection stops data breaches and helps to raise attacker actively post-compromise. Organizations must detect and respond to protect sensitive data and meet compliance requirements. How adversaries use HTTP for data exfiltration. Post uploads to external servers. Bulk data is sent to attacker controls hosts or cloud storage in a post request bodies. Get requests within coordinate data. Attacker freezes small chunks into query strings or path segments, useful for low and slow exfiltration. Use of common services. CDN exfiltration design as this guide as an upload to popular services and attack control subdomains and reputable domains. Custom headers. Data placed in the headers X data based 64 may bypass some string-based DLP. Chunked transfer multi-part large payloads split into multiple requests to avoid size thresholds. HTTPS TLS tunneling. The encrypted channel hides the payload. Detection requires TLS. Inspection. SNI analysis or metadata-based detection. Staging via cloud services. The attacker uploads to Dropbox, GitHub, Git, Guest, and then fetches externally. Adversaries adapt low and slow approach, encryption, encoding, and use of legitimate service to evade detection. Indicators of attack. IOS. Common network indicators. Usually large HTTP post requests to external unexpected hosts. HTTP requests to domains with low reputation, rare seen in the baseline traffic. Frequent small requests beginning to the same host, followed by large uploads, chunked or multi-part transfers, where multi-requests compose a large file. Let's examine HTTP logs. In this plugin C, we can find indicators of the data exfiltration attempt in the logs. Let me see. Where do we have this one? Let me see what we need to do. Index data exfil. Resource type. So just fix resource type. DNS to HTTP. And we have got. We finally got it. So now, let me method close this one. And we got 3,075 events. So let's now look at average amount of bytes sent out to various domains as shown below. Let me filter this one. Stop count AVG. Oh, it's this one. Max min by the min. This is it. Max by Z. Min by Z. Average. I guess this is what it is. Cloud sync services. Same average points. Okay, let me see. So we got minus count. Let me minus count this one. So minus count. So we got this one. Very suspicious. Very suspicious. And sort by set. We got URL. I don't see URL in here. Table. Let me duplicate this one real quick and fix this starts with a table and send void send the what? Send void set. Send more than 600. Now this one I will fix with a table time source domain void set. Let me see. Not count void set. Okay. Test IP. I've just missed test IP. That's a domain. Test IP. No data IP for this one. DST. Okay. Now let me jump real quick to the HTTP Exfil. See HTTP upload. I can follow HTTP. And we finally got him. Nope. I did it. Have the objects. Yeah. Let me see the largest one. This is it. This is the largest one. Displayed one. Maybe see? I don't need to save this one. So mad and boast. HTTP request method post and following len bigger than 500. We have destination. And we have display 1177. Now, if I will take this one, 750, I got only one suspect. And we have this. Hashes for secret Exfil. Password gateways. 2. So which internal compromised host was used to exploit these sensitive data? Here we go. That's it. So now what's the question? What were the hidden inside exfiltrated data? I don't see this. Oh, here we go. That's it. Now we have the last one. ICMP. The one and only ICMP is a network layer protocol used for diagnostic and control, ping, DDL, time to live. Because it is commonly allowed through firewalls, and typically it's not commonly allowed, let's be fair, and typically inspected less strictly than TCP/UDP attackers sometimes abuse ICMP to tunnel and exfiltrate data. Malicious sector encode data into ICMP payloads. Echo request reply timestamp info and send it to remote listener under their control. How adversaries use ICMP for exfiltration. Common techniques. ICMP echo type 8, replay type 0, tunneling, attacker place encoded, paste 64 hex chunk of the file inside ICMP payloads to remote servers. Server collects and decodes them. Custom ICMP types using uncommon ICMP types among zero codes to avoid signature-based detections, fragmentations, and reassembly. Large payloads are split across multiple packets. Encryption and obfuscation. Encrypting and encoding payloads paste64 is counted to look like random data indicators that sometimes may be malicious. Persistent ICMP session to an external host not used for legitimate monitoring. Unusual large ICMP payloads or frequent ICMP with payload typically pink site. ICMP payloads that contain high entropy data or patterns consist with base 64 hex bursts of ICMP are immediately followed by no other legitimate application traffic from the same host. Indicators of attack IOAs. Inversion look for the following. We have in here ICMP lab. So let me ICMP nothing. No type or code. Type 8. Okay. Need a message protocol. No response. Or ICMP type 0. The same result. Cut this one. Let me see if we have the payload in here. ICMP payload. Nope. And free then or bigger than what? Let's see. 34. That's it. Here we go. Let me copy this one. Whoa. What's that? Do we have in here? Cyberchi? Let me see. No, follow. Okay. Let me check this one real quick. So very, very interesting. Type 8. We have this big chunk of echo. Standard echo is 30. And then we have this one. 148. don't see how. Let me. Nope. We have 100. Nope. Oh, that's it. What we do have is password. Read only 20. What is the flaw found? This is not the flaw. Let me check quick for the flag. We have the flag. Show packet bytes. Decode S. It's what? Okay. Decode S. Shape. And DNS. Decode. Let me copy the value. Copy. Down. Yes. Down. Yes. This string. Let me see. This is it. Etched success. Go, baby. We got this one. That is it for this room. This room only touches a few channels used for data exfiltration and a network-centric log. Sources defined for print and data being sent out of the organization. So the fundamentals what data exfiltration is and why it's critical threat to organization. The target frameworks how data exfiltration fits in an established model like cyber culture, actions on objectives, common techniques, and various methods that are used to steal data include FTP, HTTP, DNS, ICMP tunnel. That's it. Very nice. Thank you very much. We will be back soon.